All right, so we're continuing 6.5, solving exponential equations. And then just remember that the key to solving any exponential equation is to make sure that you get the same base. Once you get the same base, you set the exponents equal to each other. And then a hint or a tip is always take a look, if you don't have the same base on each side of the equation, always take a look at the smaller base and then try to rewrite the other side of the equation in terms of that base. So here's what I mean by that. For this example, I don't have the same base. The base on the left side of the equation is 4, and then on the right side is 1,024. Those are definitely not the same. So what I'm going to try to do is rewrite 1,024 in terms of the base 4 to some exponent, and then see if that's equal to 1,024. So I'm trying to figure out 4 to what power is 1,024, if it is. So you might just need to kind of mess around on your calculator. Like you can try 4 squared, that's going to be way too small. 4 squared is 16. Then you might try 4 cubed, and then that's too small as well. 4 cubed is 64. So then I might try something like, 4 to the 6th. If I try 4 to the 6th, that's 4,096, so that's too big. Now I could try 4 to the 5th power, and then that works. So 4 to the 5th power is 1,024. Now I do have the same base. On the left side, we started with 4 to the 2x plus 11. The bases are exactly the same, so then we could set the exponents equal to each other because I have the variable in the exponent. So now 2x plus 11 is equal to 5. And then you can solve that equation. Subtract 11 from each side. 2x is equal to 5 minus 11 is negative 6. Divide each side by 2. And then x is equal to negative 3. And then you can go back and check that solution. So if I plug this back into the left side of the equation, everything that I started off with in green here, 2 times negative 3 for the exponent is negative 6, plus 11 is 5. 4 to the 5th on the left side of the equation. Let me just write it down. This is my check. 4 to the 5th should equal 1,024. And we checked that earlier. 4 to the 5th is 1,024. That's how we got the same base. So x equals negative 3 is a correct solution. On example 2, again, we don't have the same base. The base on each side of the equation, on the left side, it's 49. On the right side, it's 343. So like I said on the last example, try to look at the smaller base, 49, and see if you can rewrite 343 in terms of 49 to some exponent. So again, just using your calculator, you might try 49 squared. 49 squared is 2,041. So that doesn't work. And then we run into a problem because if we take 49 to the 3rd power or 49 cubed, that's going to be way too big as well. And then you might think, well, you can't solve this equation because you can't get the same base. So in this case, we might need to change each of the bases. Here's what you should try to recognize. 49, that's 7 squared. So you need to know your multiplication tables. So I'm going to rewrite this as 7 squared. That's 49, but that's raised to the x minus 2 power. Now I'm going to try to rewrite 343 in terms of the base 7. So if you take 7 to the 3rd power, that's 343. You shouldn't really need to try to check 7 squared because you should know that's 49. That's too small. But 343 is 7 to the 3rd power. Now I have the same base, but on the left side, I need to use a power of a power property for exponents. So I would multiply 2 by the quantity x minus 2. That means distribute. So 7 to the 2 times x is 2x. 2 times negative 2 is negative 4. And that's equal 7 to the 3rd power. I have this exact same base now, so I could set the exponents equal to each other. 2x minus 4 is equal to 3. And then solve that for the variable. Add 4 to each side. 2x is equal to 4 plus 3, 7. X is equal to, if I divide each side by 2, 7 halves or 3.5. And since I have a decimal, I'm going to check that on the left side of the equation. Go back to the original equation, which here in like the maroonish color. 3.5 minus 2 for the exponent is 1.5. And then you could check on your calculator. 49 to the 1.5 or 1.5 power is 343. We haven't really talked about decimals or possibly fractions as exponents, but you can have that. So 3.5 is what checks in that equation.